Good afternoon once again. Today we are going to discuss the harmonic oscillator problem using perturbed Hamiltonian. Let's consider H is equal to H0 is the Hamiltonian of the unperturbed system. Here we are going to consider a harmonic oscillator. Harmonic oscillator problem. We know that there are different type of oscillators like simple pendulum or consider the motion of a particle and consider the motion of a particle or charged particle in an oscillating field or in the presence of an electric field in the positive x-axis, or let's consider a simple pendulum which is moving with a particular constant velocity, or consider a sine wave, cos wave, or anything. There are different type of simple harmonic oscillations are there that are repeating after a particular interval of time. After a time period, the oscillation is repeating. So here we want to consider a mass of particle with a mass m and which vibrating or rotating or oscillating with an angular frequency omega. So the unperturbed Hamiltonian, that is equal to the total energy operator H, that is equal to E, or H of psi is equal to E of psi, that is equal to kinetic energy plus potential energy, that is equal to the kinetic energy that we know that half mv square, that half mv square that we can be write it as in terms of quantum mechanics, we can write it as p square by 2m plus half m omega square x square. Let's consider this is the unperturbed Hamiltonian or H0 in the case of a simple harmonic oscillator. Now, we apply an additional potential by the application of an electric field. Let's consider this is a charged particle by the application of electric potential. Then additional field, if electric field is present there from positive to negative, capital E is present there. Then this electric field also affect this one. Or here also any air resistance or we give some additional energy, we touch here at this point of oscillation. Or when we give an additional potential to system, let's consider I taken as, let's consider half bx square. At half bx square is the additional potential that is given to the system. So this is the unperturbed Hamiltonian, and the energy value, as we also know that the energy value of a harmonic oscillator in an unperturbed system is equal to n plus 1 by 2 into h hat omega, where n is equal to 0, 1, 2, etc. and n is equal to 0 for the ground state. This much of knowledge we know. Now we adding this much of potential to this potential energy. Then our potential energy V become V is equal to half m omega square x square plus half b x square. So this is our total potential energy become like this. So we can write it as our Hamiltonian, new Hamiltonian, H is equal to H0 plus, let's consider S prime or lambda H dash, or the change in Hamiltonian due to very small perturbation or very tiny change in this oscillation. So that's H is equal to P square, substitute equation number 1, P square by 2m plus half m omega square x square plus this constant also plus half bx square. It is write it as H is equal to this much of value, that is H0, that's equal to H0 plus that's equal to H of dash. So this is our new Hamiltonian for our system. Let's consider this is equation number 2. The both case 1 and 2 for the unperturbed system, unperturbation, and this is equation number 3 for the perturbed system. And now we are going to find out the energy value, or what is the energy value or change in energy. Here we know that the change in, here in this case, unperturbed system, there is only E0. So if the change in energy, then we can write it as E equal to E0 plus first order perturbation plus second order perturbation, etc. And in last classes, we discussed we can neglect the perturbation increases, order of perturbation increases, the additional values decreases. We can only consider up to the second order term. So we can write it as E is equal to E0 plus E dash plus E square or E1 plus E2. Now this value is our known value. That is equation number 1. That is equation number 2. That is equal to n plus 1 by 2 h at omega. Now we want to find out this E dash and E2 or second order perturbation in n. So first of all, we want to calculate this E1 or E1 of any level n. So in last classes, we calculate the expression for the first order perturbation that was like this. En of 1 is equal to n h prime n. Bra n state into changed Hamiltonian into ket n. Here what is our h dash? Perturbed Hamiltonian, h dash is equal to half bx square. You can also solve all the problems like this. If you have any problem, a mathematical problem in quantum mechanics to solve the perturbation theory and find out the eigenvalues for first order or second order, you just substitute the perturbed Hamiltonian here. And you just solve this equation and find out the first order energy eigenvalue equation. Now this is equal to n half bx square n. Then b is a constant and half is a constant. We can take outside half b n x square n. So that you can write it as, consider this is for the ground state energy. Then E0 of 1 is equal to half into b into n x square n. Let's consider this is equation number 4. And for the, now consider the second order. This is the first order perturbation. Now we can consider the second order term or second order perturbation. So En of 2, in last classes we discussed this value. En of 2 is equal to summation over m not equal to n. Then n h prime m modulus square divided by E0 of the state minus E0 of this state, or Em of 0 or En of 0. Anyway, we can write it as En of 0. The change in energy between these two levels, N and M. So here also we can substitute the value of h dash, that is equal to summation over m not equal to n half bx square m whole square modulus square divided by n of 0 minus n of 0. We can take it outside. That's equal to summation over, here the square of 1 by 2, that is equal to 1 by 4 into b square into, or we can write this summation inside this here, into n x square m whole square divided by E0 of n minus E0 of n, or En of 0 minus Em of 0. So the final expression for that one, E0 of 2 become, that is equal to 1 by 4 B square summation over nx square m the whole square divided by En of 0 minus Em of 0. So these are the two values that we obtained to calculate. This is E0 of 2, this is E0 of 1. And also we know that E0, or here we can also write that value, that is equal to E0 is equal to n plus 1 by 2 into h hat omega. Now our aim is to find out these two values. We want to calculate this value, we want to calculate this value, we know this value, and add these three values, then we all obtain the total energy is equal to E0 plus E0 of first order plus E0 of second order. So this is our aim. Now we want to calculate these two values of this equation number 4 and equation number 5. And we want to add all these equation 2, 4, 5, then we obtain the total solution E is equal to E0 plus E1 plus E2. Now we want to calculate this expression for this one and this one in terms of creation and annihilation operator. Actually, for a simple harmonic oscillator, this value of x in terms of creation and annihilation operator, we can write it as, here we can write here, you just remember these values. Let's consider our x, the value of x become x equal to h hat by 2 m omega all raised to 1 by 2, or root of h hat by 2 m omega into a plus a plus, or a dagger. Here a is the lowering operator or annihilation operator. A plus is the creation operator. If we operate A with any ket state 1, then it becomes 0. If we operate A plus with A1 ket, that becomes 2. Actually, this is meaning. A ket value is increasing by operating with this creation and annihilation operator. But if we operate A with 0, A of 0 becomes 0, and A dagger of 0 become 1. We want to know these values to solve this equation. So we can substitute this value of x into this even. So we can start here. Our E0 1 is equal to half into b into n into x. We just replace this equation into here and consider this is equation number, any equation number we can write it as, this is equation number 6. Then substitute equation number 6 into this equation number 4. Then our E0 of 1 become, here half into b is there, n is there, into x square. You can take the square, half into 2 become 1. So h hat by 2 m omega into a plus a into x square. So it's all square into m. But we have square root പോയി അത് 1 ആയി. ഇനി ഇതിന്റെ സ്ക്വയർ കണ്ടുപിടിക്കും. എന്നിട്ട് ആ സ്ക്വയർ കണ്ടുപിടിച്ച് ഇതിലേക്ക് ആഡ് ചെയ്യും. So E0 of 1, our new term E0 of 1 become half into b into h hat divided by 2m omega into a plus whole square divided by m. That's equal to 1 by 2 into b into h hat divided by 2m omega into n a plus a dagger whole square. Yeah. Now we want to solve for this equation. We want to find out the value of this a plus a dagger whole square, or a annihilation operator plus creation operator whole square. Now we can solve this value and we can substitute here. Let's consider a plus a Hermitian, a plus, not a Hermitian, a creation operator whole square is equal to a plus a creation into a plus a creation. Then by using quantum mechanics multiplication, a into a plus a into a Hermitian, a creation plus a creation into a plus a creation into a creation operator. The value is obtained like this. Now we can substitute this value for each value. This is the first value, this is second value, third value. For each value we want to calculate. Let's consider any state 0, a, 0. That will become, it is annihilation operator, then 0 becomes 0 itself. Already we write that. A of annihilation operator of 0 become 0 itself. So that becomes 0. 1 is operated, so 1 is remaining there. A 0. Again, we are operating with this creation operator. Annihilation operator with 0, that becomes 0. So the first time become total value becomes 0. So this time is here. This become 0. Now consider the second time. We can operate 0, a creation 0. That's equal to 0, a plus, or a creation 0 become 1. That's equal to, again, this annihilation operator, then reduce to 0. 0, 1. That become, sorry, a1 when you operate it become 0. Because it's annihilation, ഒരു value കുറഞ്ഞു വരും. So 0, a1 becomes 0, 0. That means delta of 0, 0. When both m is equal to n, this value become 1. So here, the second time become 1. Now consider the third time, or same procedure. We can simply do it as third time 0, a creation, a annihilation of 0. First we do this to become 0, 0, a Hermitian, a creation 0. Again it will become, one value increases, then it is equal to 0, 1. That is equal to delta 0, 1. That is equal to m not equal to n. Or not become a conical delta function, this become 0. And also the last value, here we can write it as it's again 0. The final value for 0, a Hermitian, sorry, a creation 0 become 0, a creation 1. Again it become, here we want to know one value. When a creation operates with any m operator, then that value become root of m plus 1 into ket of m plus 1. It's equal to root of 1 plus 1 means root 2. It's equal to 0, root 2 into 2 m plus 1. Here m equal to 1. Root of 1 plus 1, root 2 into 2. That's also root 2 into 0, 2. That's also delta 0, 2. That also 0. So when you operate this whole value, we only one value is there that is equal to 1. So the total value become 1. All other value become 0. So here substitute here, it is only the value 1. So our first order energy value or E01 become half into B into H hat by 2 m omega into this operation. We just substituted ground state 0, 0 for every value. M and M consider as 0. Then only this value is equal to 1. So the final value of E0 dash or E0 first order eigenvalue of energy for a simple harmonic oscillator then become half into H hat by 2 m omega into B. That is equation number 7. Now we obtain the value for E0 and E dash. The value of E0 become n plus 1 by 2 into H hat omega. And E01 become half into H hat divided by 2m omega into small b. Now we can calculate the second order perturbation or second order correction in terms of energy. So that is E0 or E0 of 2. Our equation is equal to, our equation become summation over m not equal to n. So we cannot be considered as 0 bracket 0, 0. We can just take any another word, 0, 1 or any another. Here I am going to take ket 0, brass 0, ket m. I'm going to operate with the E0 of 2. That is our final equation. We already write it as 1 by 4 b square. That is our equation number 5 into summation over n x square m modulus of O square divided by En of 0 minus Em of 0. Here this order you just choose. Here it is n, En. If it is m, Em of 0 minus En of 0. That is our equation number 5. Here I am going to add 0 here, add m here. So we can also be write it as that is equal to 1 by 4 b square into summation over n. Our x value is H hat divided by 2 m omega all raised to 1 by 2 into A plus A creation into M all square by n of 0 minus n of 0. Then that become, here there is a square inside the here, x square. Actually, there is a square inside. And also there is a square in outside. So here that's equal to 1 by 4 b square summation n. In the square എടുക്കുമ്പോൾ we have to take this square into here 2 by 2 1. That's equal to h hat by 2 omega. H hat by 2 m omega into a plus a Hermitian all square into m modulus square by en0 minus. That's equal to 1 by 4 b square summation over, you can take this value again square, then you can take the square of that value. So remove this. So here we can write it as h hat by 2 m omega all square into summation over 0. Given here it is 0 and this is m. A plus a creation whole square into m square divided by En0 minus En0. That's equal to, here also we want to find out this value. This value we want to find out here. And substituting in this case, then we can solve here. So we want to calculate A plus A creation all square into M. So A plus A Hermitian all square. A plus A creation all square become A plus A creation into A plus A creation. That's equal to A plus A creation plus A creation A plus A creation. Into we can operate this value with 0 and 8. Yeah. Now we can take each case. For the first term, 0 M. That's equal to this annihilation. So it become, if in the case of annihilation, it become, that means A of M equal to root of same value M into ket of annihilation. That is, one is decrease M minus 1. So you just do like that. That's equal to 0, 0. 1 is there. It is operated, and that become root M into M minus 1. Again, this annihilation is operated. Then that's equal to root of M. Already is there. Then we operate with A with M minus 1. That is equal to root of M minus 1 into 0 M minus 2. So that means root of M into root of M minus 1 into delta of 0 M minus 2. There is one chance is there. It becomes 0, 0. If M equal to 2, that is equal to root 2 into root 2 minus 1. Delta of 0, 2 minus 2, 0, 1. So that is equal to root 2 into root 1 into delta 0, 0. That's equal to conical delta 1. Then that value become root 2. So in this case, the first term become root 2. Now consider the operation of second term. You can write it in a new screen. It's very simple actually. So A creation 0 M. That's equal. When we operate with the M, it will become root of M plus 1 into ket M plus 1. So root of M plus 1, 0, A is there into ket M plus 1. Again, annihilation operator is there, then it will become M. Root of M minus 1. This one here. Root of annihilation, there is no change. M plus 1 into 0. Annihilation, that is equal to. There is no chance to make this value 0 M. If it is 2, only the case is 0. And it will become minus 1 and 0 plus 1. Minus 1. Then the state is not be possible. If there is any chance greater than 2, 0, then 1 minus 1 becomes 0. For other cases, this M is not become, or this 2 ket state not become same. So it is also be delta 0 M. There is no any particular value 1 or 2 or 3. Not ground state 0. No other cases, energy values 1, 2, 3, etc. Not possible to become these two terms become same value. So it is a delta of 0 M that becomes 0. So our term, second term, this becomes 0. Now consider our third term. A Hermitian, sorry, a creation A of M0. That is equal to this value root M 0, a Hermitian, then annihilation operator operating M minus 1. It is operating, it will become plus 1. And here also root value become plus 1. That is equal to root M into root M minus 1 plus 1, root M into 0. It's also delta 0 M. So, or 1 or 2 or anything value, this not be become same except 0. So, this also value delta 0 M, M not equal to 0. So, this value also 0. So, the third term also becomes 0. Now, consider the fourth case, a creation that is equal to 0. A creation of M that's equal to 0. Then we can write here a creation that is equal to root of M plus 1, 0, a Hermitian, sorry, a creation into M plus 1. Again, we operating it with the creation operator, root of M plus 1, root of M plus 2, 0, M plus 2. So that become delta of 0, M plus 2. It may be become 0 only for M negative value and not be possible. M values only from 1, 2, 3, etc. M not equal to take, you just don't take M equal to 0 and negative values. Or M not become 0 or any negative. So this term also be delta of 0, M plus 2, that's also 0. So that term will also become 0. So our total value of this value become root 2. Now we can substitute this value here. That's become, that is equal to 1 by 4 into B square into H hat divided by 2 M omega whole square into this value is equal to root 2 square divided by En0 minus Em0. If nth level is, if here we can second order. So here if n equal to 0 and m equal to 2, then that this term become E0 minus E2. That is equal to second energy level to ground state. Then one energy level quantized with H hat omega. So it's also H hat omega. So 2 H hat omega. It is taken from here to here, 0 to less value to higher value. So this term become minus 2 H hat omega. This term, the lower term. So we can write it as 1 by 4 B square H hat square divided by 4 M square omega square into root 2 into root 2 divided by minus 2 H hat. That's equal to 4 into 4. The negative sign is there, negative of 4 into 4, 16. We can cancel this 2. 1 by 16 into, there is a B square into H hat square cancel. There's H hat in upper side divided by M square into omega. So also a final equation become minus B square by 60 into H hat divided by M square omega. This is the final equation for our E0 of 2. So we obtain the three values are there. E0 is half h hat omega. E1 is half h hat divided by 2m omega into b. And E2 is 0 of 2 become minus b square by 16 into h hat divided by m square omega. So our final expression, simply the addition of these all terms, then the total energy become the addition of E0. So E equal to E0 of 0 plus E0 of first order plus E0 of second order. So E total energy value become E equal to half h hat omega plus half into h hat by 2m omega into b plus, minus is there, minus 1 by 16 into b square. So we can write this b into here. B square into h hat divided by m square omega. Just be rearranging half into h hat omega plus half into b into h hat divided by 2m omega minus 1 by 16 into b square into h hat divided by m square. So this is our final expression for the eigenvalue of energy of the ground state of a simple harmonic oscillator by considering the first and second order harmonic. So we know the first order equation, we know the second order equation. If we know any h prime, we substitute the h prime value in this case, in this E1 and E2, then take the creation and annihilation operator, and just solve. We obtain the final values and substitute in our equation, we obtain the final solution. So this is the final solution for the harmonic oscillator problem. In the case of there is a small amount of perturbation is there and a small amount of perturbation half b into x pi. So this is our final equation. It's a very nice derivation. Thank you all.